Okay, acid nomenclature, which is essentially just naming acids. Before we get started, I want you to look at these 5 examples here, press pause, and when you press pause, try and do these for a second. Just try and do them without any instruction. Okay, hopefully you press pause, and now you're back. If your paper looks like this, awesome, means you got it. If not, we're going to make sure you understand why these are named and written out the way they are, so make sure you're paying attention. During this video, obviously you're going to watch. I want you to fill in your guided notes, and then at the end I want you to look at these 5 examples here. At the end of the video and before next class, I want you to do these 5 examples on your own. I will not give you the answers in this video, but we will go ahead and look at the answers in class. But I want you to try these and come with some questions or some thoughts when you're trying these without the answers in front of you. Real quick, what is an acid? Let me talk through and then press pause and copy this stuff down. An acid is a solution containing the hydrogen cation, which is H+, there's a hydrogen cation, and an anion. Okay? We know the formula, we know it's an acid when it has an H at the beginning. It has an H at the beginning. And then lastly, acids are just like the other compounds where they are balanced, I should say. Balanced compounds. Okay? And so the cation and the anion charges need to be balanced just like ionic and polyatomic compounds. So we have a plus and a negative charge. When we put them together, we have to make sure that they equal each other out. Go ahead and press pause. Make sure you get this down. Okay, so how do we name acids? We're working with 2 different types of binary acids. Again, let me speak through and then press pause and get this down. Binary acids, okay, binary acids are a hydrogen and one other element as the anion. There's only one exception, and that's HCN. As HCN, you can see it's a hydrogen and 2 other elements. That's the only exception. We're going to call that one a binary still. The next is oxyacids, which is essentially a hydrogen and a polyatomic anion. So if it's a hydrogen and one other, we're looking at binary. Remember, bi means 2. Think bicycle. And then oxyacids, hydrogen, and polyatomic. Let's walk through. Here are our rules. For binary acids, you give them a hydro. Okay, name it hydro. For the suffix, because it's a binary compound, it's going to end in an "ide." You change that "ide" to "ic." So "ide" goes to "ic." And then after you put it in there, you put acid at the end of it. So for example, hydrochloric. This is a hydrogen and a chlorine. You see how it's H+ and Cl-, hydrogen, chlorine, they're balanced. So we put the hydro, chlorine, and then you see how we've got the "ic" at the end because it's hydrogen chloride. "Ide" becomes "ic", and then we add acid. Hydrosulfuric acid, H2S, again 2. We've got the H+ and the S2-, and that's why you've got to have 2 H's to balance out these 2 negatives. Now, with sulfur becomes sulfide, and something special happens here with sulfur, where sulfur actually puts the UR back in, so it becomes hydrosulfuric. And again, sulfur usually goes to sulfide, okay? And so it's not sulfic, we put the UR back, and that's for all of them. Whenever you see a sulfur compound as an acid, you put the UR back in. And then HCN, this is your one exception. HCN is a polyatomic cyanide there, but we call it a binary and we name it as such, so this becomes hydrocyanic acid. It's hydrocyanic acid. There's your "ic" right there. Okay, oxyacids are a little bit different. Oxyacids, no hydro. Okay, and this is where the suffix people struggle a little bit. If it ends in 8, you change it to ick. The way I remember that, if you ate something bad, you say ick. You ate an acid, you say ick. Think of like orange juice. You drink orange juice, it's too acidic, so you ate it and you said ick. And then if it ends in ite, you go to ous. Ite, os. Ite, os. I don't know. It sounds German, something like that. However you remember that. Okay, ate to ick, ite to os. Alright, and then again you add acids to the end of the name. So here you go. We've got chlorous acid. Okay, chlorous. So this is a chlorite anion. This is chlorite. And this ite goes to us. Alright, no hydro in front. You just take chlorous or chlorite, make it chlorous, and put the acid at the end. Again, if you see, I've got an H at the beginning, and that's the way I know it's an acid. ClO3, HClO3 is chloric acid, and that's because ClO3 minus is chlorate. So the 8 goes to ick, 8 to ick. And then H2SO4, sulfuric acid. Okay, I've got my H plus and my SO4 2 minus, and that's why I gotta have 2 H's here. H2SO4 becomes sulfuric, and that's that UR coming back in. Okay, SO4 is sulfate. Okay, so I take the sul, put the UR back in, take out the 8, and put the ick, sulfuric acid. Okay, make sure you get what's written in type, and then my annotations on there too. And these are your rules, guys. This table right here, the reason I made it big in your notes is so you can have this nice and big, and you can come back to it. And these are really the last naming rules we're going to worry about. So once you get this, it's really only 5 different things, and it's just keeping them all straight. Okay, so a couple examples together. If you want to press pause right now and try these first as practice, and then listen to me walk through, that's a great idea. Or just watch me walk through and try and get it that way. I've got HBr. I see this as an H and a Br. I see 2 elements, all right? And so I think that's a binary. So if I go back to my rules, by binary, I put hydro. Okay, I would add the hydro. And I know this is bromide, and so I put bro. And instead of the ide, I put the ick, ide to ick. Okay, hydro, bromic, and then I add acid at the end. For the next one, a hydrofluoric acid, I see here that it starts with a hydro, so I'm thinking binary. Okay, and then to confirm, I've got the ick. So I start with my H. When doing acids, always start with your H. And I know it's H plus, so let's do it this way. And I look at fluorine on my periodic table. Okay, I know that fluorine is 1 minus, and so I can just write hydrofluoric acid as HF. The plus balances out the minus. Okay. HNO3. I see 1, 2, 3 different elements. So I know it's a polyatomic, which gives me an oxyacid. So I'm going to go to the polyatomic side of my yellow sheet, my support sheet, and I'm going to see that NO3, if I pull that away, NO3 minus as the anion is nitrate. And then obviously I have my H plus. Well, the nice thing about this is 1 plus 1 minus, they balance each other out. So I know it's a polyatomic, so no hydro. I've got an 8. So if I look back at my table, I change 8 to ick, and all I do is nitric acid. Okay? The reason I put this next one, nitrous acid, is it's just a little bit different. To work backwards, if I see there's no hydro, I know it's a polyatomic, okay? And so I can look before the us and look at NITR. Alright, so I know that's in the nitrate, nitric family there. And I know that OUS comes from ITE, alright? And so I just put those together. And okay, nitrite, and oh, look at that. My nitrite ion is an O2 minus. Okay? And then I know I'm balancing it out with an H plus, so 1 minus, 1H plus, I can write it as HNO2. And that's my balanced nitrous acid. These next two get a little tough. See how I've got hydrogen sulfurous acid? Don't be tricked. This is not the same hydro. Okay? This is hydrogen sulfurous acid, which, if you look at that long name, that's a polyatomic. And when I look at my polyatomic list about halfway down, I see hydrogen sulfite. Hydrogen sulfite, okay? Hydrogen sulfite is HSO3. That's the anion, okay? And to make it an acid, I mix it with an H plus. They balance each other out, 1 to 1, okay? Now, I want to make sure we write this properly. You don't put the H and then this again. This is not correct. Okay, HHSO3, where I've got my hydrogen, then I've got my hydrogen sulfurous. I don't do that, so I'm going to put a big red X around that. That is not, oops, let's make that red. That is not correct. What I want to do is just combine those H's, all right? And I can write it as H2SO3. That is hydrogen sulfurous acid. Okay, the last one is very similar, H2CrO4. Okay, now I can look and see if this is a polyatomic here. All right, and what I do is I find that CrO4, if I look, about 3/4 of the way down, CrO4 is chromate, and that's a 2 minus, is the chromate. Okay, and if I want to mix that with an H, I've got H plus. Well, I've got 2 minus, 1 plus, which makes me have to add in 2 H's. So that's where I get my H2 there. Different than this H2 over here. Okay, this H2 is there because it needs to balance out the chromate. Okay, now when I want to name this chromate, remember, 8 to ic, so it is just chromic acid. Okay. Please make sure that your notes are filled in from this video. Go back if you need to, and then I want you to try these 5 examples and come to class ready to go over them either with solutions or questions. Thank you.